Great. Thank you all first for joining here in this session by Belfius. And as you can see, we'll be talking about transforming banking with advanced AI. And we'll deep dive in a few topics here, specifically GenAI, RAG systems, and multi-agent systems. Now, I have a quick question. Can I get a hands up for those who, if I say RAG, understand fully what we're talking about, or totally not? So can I get a hands up if you know RAG fully in and out? It's okay. Good. This is a beginner session, so I think it's perfect for a lot of you. So it's a talk by Belfius, and as you can see, meaningful and inspiring for the Belfius society, for the Belgium society. Belfius is a bank insurance company in Belgium, for those who don't know. We have a big local anchoring, which means we invest in local projects, we invest in local individuals, and most of all for us, digital innovation is an important topic, and that's also why we're here today, to show you what we're doing. Most of the things you'll be seeing today are based on real-life business use cases that we've seen happening in our company, and I want to share some experiences with you today. So who am I? My name is Kevin Suys. I'm working for about 10 years now professionally with AI, and at Belfius, my job title officially is a lead engineer. I started out at Belfius in search projects, and there we were using keyword search, which quickly evolved into semantic search, and we were using Elasticsearch as a backend for that. I had a few other projects also. I was working on classical chatbot platforms, and when combining both, we actually came to RAG and GenAI as a logical sequence for those. Now, let's take a step back first, and I've seen a lot of presentations diving really deep into RAG and getting into the technical things without telling maybe a bit about the history and where we're coming from. So, first of all, 1950s, a long time ago, you had a guy called Alan Turing who did the actual definition of what is machine intelligence, what do we want to say with that. And then it went a bit quiet, and a lot of people, they call it like there was a winter happening. Nothing really was evolving. We had that machine intelligence definition, and then 1990s came, and that was actually my first introduction to AI, neural networks. And you had a few different neural networks. You had CNN, or convolutional neural networks, or RNNs, the recurrent neural networks. Now, the convolutional, you could see that as they could support vision things. They might have been used in things like OCR, for instance. The RNN, you could say that they could work like an autocorrect. So those were two types of different neural networks that already were happening in the 90s. And I was back in school, and that was my first encounter then. Then, quite a bit later, all of a sudden we get a big jump. We get IBM Watson that was presented, which was really about deep learning and really taking the next big step in things. You had voice assistants like Alexa and Siri popping up. And we were talking all of a sudden about transformers and GPT models. We were hitting the next level in the evolution, let's say. And then we come closer to today, 2020s. GPT, it's all of a sudden we had GPT-3 by a company called OpenAI. And they also quickly after, they introduced the 3.5 version of, as we know, ChatGPT. So the next level emerges of the evolution, and then we see also the RAG principles coming up. So RAG is one of the topics we'll talk about today, and RAG, if you don't know it, it is an acronym. It stands for Retrieval-Augmented Generation. And I'll show you the different parts that it consists of. Now, all this had, as a meaning, it really did a boost in GenAI. Everybody is talking about GenAI, and that's probably also the reason why you're here, and in this specific conference on GenAI, and in this specific room, really. So what do we have today, and what are we looking at the future? So RAG is evolving. It's a very nice principle, but it's really new. It only exists, I don't know, should I say almost 2 years, maybe? I know I did an early presentation internally about 2.5 years ago, when I think the RAG was not called RAG yet at that time. But looking at today and looking at the possible future and those evolutions of RAG, we're looking at the agentic frameworks and possibly also autonomous learning and autonomous execution. So, where do we use AI at Belfius? Well, to start off with, AI has different parts. And here I put a distinction between two. On the left side, you can see the predictive AI part. So this is really predictive algorithms. They can assign probabilities, they can try to categorize outcomes, and they can be in support of different decisions. So predictive. On the other side, you've got generative AI, and that's what we're probably going to talk about today. This is generative algorithms that can create text, it can create images on a human level quality, that's important. And yeah, most of the time in response to a request or a prompt. So let's have a quick look and see what we're actually doing at Belfius. So on the left side, the predictive side, we can do fraud detection, for instance, to see what's happening with our transactions. We have transaction monitoring for that. We could apply some churn analytics to see actually what is happening, why should something be happening, when is it going to happen. And there's also categorization and routing that can be supported by this predictive AI. On the other side, you had the generative part. So that's where we, for instance, had an internal GPT. For my colleagues of Belfius, they should know about those things. We can have coding assistants. I think that's really an upcoming, and I think a lot of you will be joining sessions today or in the coming days about coding assistants in your favorite IDE. And we have also knowledge systems based on RAG. That's going to be our talk today. And of course, smart search. Search can be enhanced, and it can be enhanced with AI. So let's zoom in on this principle of RAG. What actually is RAG? Again, it was a colleague of mine that actually added this picture, so I really like it. Imagine that myself, I'm working at Belfius, I have a specific question, and I know that the answer should be somewhere in our documentation systems. And it can be, I'm IT, so I could have an IT-related question. On the business side, they will probably have business-related questions, but imagine that I have a question I also gave as an example today to my colleagues. I need to open a port on the firewall, and I don't know exactly what I need to do. But I know that somewhere we have Confluence, a nice information system, and I know it's described there on, somewhere. But I don't know where exactly, and I could go and do the traditional search and dig through numerous pages until I get my real answer. What I can do is I can apply RAG principle. And RAG, it's Retrieval-Augmented Generation. It starts with retrieval. So what we actually do is we create a retrieval process that will fetch specific documents from our Confluence, for instance. And then we go into the augmented part, where we ask an AI, hey, I found some relevant documents to a query that the person asked. Can you formulate a nice response in a natural language? And that's basically RAG. Now, why do we deploy RAG solutions? Because you might have heard, hey, we are using LLM models, and there's big ones, there's small ones. You can create your own models. You can also fine-tune your models by retraining them, maybe. So why not just fine-tune or even create an LLM model? It's actually a good question. Let's compare both sides. Now, on the fine-tuning part, it's very interesting if you want to change the behavior of an LLM model. If you want to let it respond in a different way, in a different manner, fine-tuning is perfect for that. But it's not perfect to update factual knowledge. Also, it can be expensive, and mostly it's time-consuming to do it. And in the end, you still don't have access to real-time information. So that's where RAG comes into play. So RAG, the retrieval mechanism, it helps us to pre-select the relevant data to the query and to the context. So we can not only give the query, we can also give more context on who's the person, which domain, do I need to respond in a technical way, or does this need to go to a customer maybe in response, maybe I should add a specific tone of voice. We can do that with RAG. What's also important about RAG, it forces factual grounding due to the created knowledge that we supply. Now, what does this mean? We pre-select data that we send to that AI. And we tell that AI only use this data to respond to the query. So we're sure, or we hope, that this can prevent hallucinations if the LLM struggles with the factual accuracy. Now, an LLM has a lot of knowledge, and it will always try to respond to your query, even if it's uncertain, and if it's not really well trained in your area of expertise, let's say, then it will start maybe hallucinating. It will always try to give what it thinks is a complete response, even if it doesn't have the data. Now, data. Data is key on this part, and I would like to share a few things that we also found out on our side. First of all, as we all know, garbage in means garbage out most of the time. Now, this is a real-world example, actually, of one of the data that we have internally. We have a nice management system for knowledge, and this is what is generated in the backend in the database. So if we would like to throw this data to our LLM, it will try, it will do its best to make sense out of it, but if you closely look at it, it's actually a JSON file that has escaped HTML inside, and even at the end, it has like a base64 encoded image. And business, really, they love working with this tool because it's nice. They can apply layouts, they can do some dynamic accordion elements, whatever. They can quickly upload images in there. But for an LLM, this is not really easy to understand. It will try, but mostly it will fail also. So garbage in, garbage out. So let's see, how can we clean this data? How can we make the data better prepared for AI? So how to improve your data quality? First of all, define some data quality standards. That's really, really important. You need to establish a clear criteria on what is actually the high-quality data that I need for my AI model. And make this consistent across all the teams and all the departments. And here's some key factors here. You need to look at accuracy, you need to look at completeness, and also timeliness. Is it still up to date or not? Maybe you want to check what, maybe you want to do, see if you can create a data standards project team. Can be very helpful. Second point here is data cleaning and validation procedures. You might want to use some data cleaning tools to remove things like duplicates, inconsistency, and check on the completeness. Now, these things, they seem trivial to do, but in reality, you need to implement this maybe in existing systems, because implementing something in a new system, everybody can do that, but changing your old existing systems, that's really a challenge. So maybe also look at AI, see what an LLM can help, because incorporating something in an existing workflow, not that easy, but maybe an AI can help on evaluating the quality. An important one also is to have automated testing and manual reviews, because you can say, look, we can do some data cleaning, we can run automated testing, but in the end, you still need to evaluate and make sure everything is nice and clean. Another topic, data governance. You might have a lot of data, but you need some clear ownership on that data, because you need to have somebody that's accountable for the quality and the integrity, so that you can go back and say, hey, guys, your team, really good start, but maybe you should improve quite a bit. Another one that helps on when you create your ownership is that it will probably enforce that you put some access controls in place. And this will make sure that your data keeps being of a high quality and is not being adapted by everybody else. Now, who are those people that I'm talking about? Well, these are your knowledge writers. These are the people that are writing things on your Confluence for IT, on your documentation, or your FAQ for your customers. These are all different kind of people across different teams. And what you should do is definitely see if you can provide some training courses and that they can understand on what they're actually doing and how it impacts the results coming from the GenAI. You might want to look also at using some dedicated platform tools that can already facilitate that. I know that it's not easy to switch to new tools, but it might be worth looking and re-looking at what you're doing today, which might have worked in the past, might not work very good in the future. Another one, continuous improvement and evaluation. You really need to plan some regular audits. And you want to identify these problems before they start impacting your business. And of course, and then we go a bit further towards the end, towards the, let's say, the generation part of the things, you want to track some key metrics. Like, are my responses accurate? Are my users satisfied? And is the whole system efficient? Because using LLMs can be quite a burden on your infrastructure. And last but not least, assist your GenAI. You might want to supply a glossary of all acronyms that you use to your GenAI. Think about your branded products. Also, your GenAI has no idea what a specific name means. If it's, in our case, if it's a type of bank account or a type of insurance, it has no idea. You might want to create different persona. So based on the audience, if your GenAI is talking with the person on the business side, or if your GenAI is talking to an IT technical person, you can adjust the tone of voice to suit actually that type of person. And last, here, and it seems a bit trivial also, force your GenAI to apply a relevant layout to the content. It's nice to see that the evolutions in the different models, they're able to follow instructions better. But I can tell you, like 2 years ago, if you would ask a GenAI model at the time to formulate in a nice layout, let's say, with bullet points, it wouldn't always adhere to your instructions. Nowadays, they follow instructions to the letter almost, and they're a lot better. So you can really do some demanding things regarding layout of responses. Now, we talked about data quality. This is another prerequisite that you need to take into account, and it's rather technical. It's about how do I evaluate if what my GenAI and my reg process is doing. How can I evaluate that it's correct, that it needs to be enhanced, or what? So we've got a few metrics here that I put on here. It starts off with the retrieval part, where we want to see, is the context retrieved? Is it relevant to the question and the expected answer? And we look at 2 key factors here. For those of you that are into AI, it will sound a bit familiar. We look at the precision and we look at the recall. So what does precision mean? Precision means, do the relevant chunks that are retrieved, do they actually rank higher in the retrieved context or not? So is the relevancy high enough or not? You could retrieve, like, I don't know, 100 documents, and are they sorted correctly? Then we look at the recall. And for the recall, we ask ourselves, do the retrieved chunks, do they align with the expected answer? Are they relevant enough with the ground truth? And this is how we kind of evaluate the retrieval process. Now, onto the generation. How do we evaluate that one? Well, there we want to see if the responses are actually relevant and if they're factual. Now, how do we check on this? Again, 2 criteria. We look at the answer relevancy and the faithfulness. For the relevancy, it means how relevant is the actual LLM response to the question. For the faithfulness, we want to see if the LLM response aligns with the context. So we want to detect if there are hints of hallucination. And this is how we try to determine some metrics to see, are we on the good way? Are we creating what is expected or not? Now, some key takeaways. First of all, if you want to create your data, you want to write in plain language. It's accessible to a wide audience. Even if your target group includes technical persons, you want to avoid complex or technical jargon. Why? Well, an AI model is just like a common person. He doesn't know about what is happening inside your business. He's not a technical person, but if you explain him well, he will understand what you're saying. And if you're unsure, just ask somebody else who might have a different perspective in writing than you are. You want to prioritize accuracy and double-check the facts and data before creating the information. It can be so easy to miss out on information if you're writing a document very quickly, so be careful on those accuracy points. And last year, like I said, keep track of a glossary of commonly used acronyms for a GenAI and leverage these. And same goes to product branding. It can be so easy for an AI to mess up because it doesn't understand what the name of a bank account is. So be careful on those things. Now, we talked enough about the RAG principle itself and the data part in it. So let's see if we can dive in a bit deeper. So this is full RAG explained. You will see there's 3 parts. Most of the time, the ingestion part, let's say, is quickly forgotten because data is there and it's always available and it's not really a problem. But yeah, if we look at real use cases, then we know that data can be a problem. So yeah, we spend a lot of time passing the data. So imagine, how does this flow work? On the left top side, you've got your data store somewhere, and then we start the data ingestion part. In the data ingestion part, the first step is chunking your data. Now, chunking your data means basically you're splitting your big documents. Imagine you've got a contract of a customer that you want to ingest, a contract of 84 pages. Well, you want to split those pages. I'll tell you later why. After you did the chunking, for each chunk, we'll create a vector embedding. And this is the first time that we actually use AI, because we use an AI model, and it's not really an LLM. It is a different type of model. It's an embedding model. We use an embedding model to create vector embeddings, and those will be stored in a vector database. This is the first part. Then, if we really go into business, and hey, yeah, that's me again. I have a query, then we go into the retrieval part. So I send my query to the retrieval part. The query itself will be actually transformed into an embedding. That embedding will then be compared to in the vector database with all the previously stored embeddings, and eventually we get some results out of it. An important step here is that we return to the retrieval part. There's a re-ranking. Re-ranking is something that should be their standard, and we'll dive into the re-ranking also a bit later. So once the re-ranking is done, we go into the last part, which is the generation part, and that's where we send actually both the actual query from the user and the retrieved context or documents all together to the LLM, and we say, please formulate a response in a nice, natural way, and then that generated response is sent back to the user. So this is the full RAG, including the data part. Now, let's talk about chunking and embedding. We saw already in the ingestion part, you need to create chunks, but how do you chunk? How do you split? Why do you split? Now, chunking is key. If you don't chunk, you will probably run into problems because you can feed a lot of data to your LLM. And I have to say there's a lot of evolutions right now, especially in the open source world. I think, I don't know, it's daily that multiple LLMs get updated or even created, introduced. And I think I did a quick search this week, and we have some open source models that go up to 1 million tokens. So a token, actually, what does it mean? A token is the almost equivalent of a word in a sentence. And I think on average, if you would divide a sentence of 5 words into tokens, you will probably get like 13, 14, 15 tokens. So a token can be part of a word, it can be a few characters, or it can be the whole word. It's determined by the embedding also, how the tokens are split. Now, like I said, we have some nice LLM models, open source, that go up to 1 million tokens. So you could say, hey, I can like almost send 1 million tokens, a whole book, to the LLM. And yes, in theory you can, but what we do see is that after like X amount of tokens. And I think what I saw here this week was if you have a token of, if you have an LLM model of 1 million tokens, up to 32,000 tokens, it can still comprehend what you're saying, but afterwards it starts to lose focus on the data. So there you go into the area where, I might be lucky that I get a good response. And that's an area where you don't want to be actually. So yes, in theory, it works. You don't want to be there. So that's why we do chunking. Now, there's a few different ways. First of all, you got the logical chunking, and that's kind of a naive approach first, where you could chunk even by character. You could chunk by word, you could chunk by sentence, and you could chunk by paragraph. These are all kind of naive chunking methods. And the goal is that you try to keep your content together in a logical way. If you have like a big contract with your customer, like I said, 84 pages, there will be sections that are logically attached to each other, but probably the beginning and the end, not really attached to each other logically. This is naive chunking, just splitting word, sentence, and paragraph. You can take it a bit further. You could include some overlap with a sliding window. You could say, hey, I make a chunk of one paragraph, but maybe the previous paragraph contains also relevant information. So you might want to include that one also. So that's the overlap. And why not include the next 1 or 2 sentences or paragraphs also? So you will be, yes, you will be having duplicates, let's say, or duplicated data, but it's all for the context of the data and all to keep everything logically contained with each other. These are, let's say, hard-coded principles that we can apply very easily. There is also another chain of thought, which is agentic chunking. So an agent or an agentic approach, it's basically also a small LLM. I don't know how to explain it. Logic, it's a small, basically you're calling an LLM to execute a task for you. So you could ask your LLM to determine the chunk size. You could say, hey, I'm going to try to chunk by sentence, and you could ask your LLM if it's good enough. So you could supply the whole context, the whole document, or a full paragraph, and say, if I chunk on this sentence, would it be good or not? An LLM can help you in determining that chunk size. Besides the logical chunking strategies, and I think these strategies, they're evolving quite fast, and I saw a lot of talks here talking about the naive chunking and all different chunking strategies, and one thing is in common, they're evolving really fast. And what somebody is not telling you today, might somebody else telling you tomorrow. So it's really evolving. There's also a big technical reason. You want your token consumption to be optimized. Now, if we talk to an LLM, we have a context window that is existing of X amount of tokens. And the nice thing about those LLMs, or let's say the paying LLMs, is that you pay per token. So if you would use a GPT model from OpenAI, yes, you have to pay per token. So to make sure you don't pay too much to use their models, you might want to optimize token consumption, and you want to limit the text that you send as input to them. And also, the less text that you send, the more your performance will increase. LLMs are not the fastest programs that we know, let's say. They might sometimes take a few seconds to respond. So if you can send relevant, small information, they will know how to handle it, and they get also a better focus, and they will better respond to your question. Another one that is important are multilingual embeddings. And I'll show you in a minute also how that goes. The multilingual embeddings, why do we want to use that? Because, they allow for language agnostic, both vectorization of the data, but also of the query. So imagine you've got a text in one language, you could ask a question in a different language. Another nice topic, and that should get more attention, is re-ranking or re-ranking strategies. So why do we want to re-rank, and how does it fit into our retrieval process. So you already saw here the retrieval process. We've got the query, the incoming query, we do an embedding, we get some results, and those results we want to re-rank. So why do we want to re-rank? Well, first of all, we want to improve the diversity of the top results. It might be that you get 3 or 4 results that are very similar, but they're not adding value for your LLM. So you might want to mix diversity there. You could do some personalization, some domain adaptation. So you could make sure that you get a specific response for a specific team or a specific domain that is asking a question. There's a potential for faster responses for an LLM because you send it more relevant data. And this is also definitely needed in a hybrid retrieval approach. So a hybrid retrieval approach, what is it actually? Today with RAG, I've been explaining that you create embeddings, you do a vector search in a vector database. Hybrid search is combining a vector search with the, let's say, old keyword search that we might have known from older search engines. There is still some value in using those older technologies. Combining them does give a clear advantage. Now, some risks, and how do we cover them? Something I didn't see yet a lot of times is guardrails. You do want to use guardrails in your RAG principle. And first of all, you want to use input guardrails. So input guardrails, what do they actually do? This is basically, again, an LLM call that will check. For instance, for illegal input, are you trying to jailbreak? Are you trying to do some prompt injection? Maybe some violent or hate or unethical or illegal questions that you want to avoid? You can put a guardrail in your process to avoid answering or starting even your RAG process when you encounter these things. Another one, topical check. You might not want to respond on a question that is not related to the bank. For instance, what's the capital of France? Cool that maybe the LLM can know about it, but it's not the purpose of maybe your RAG program that you're building. And the third one is maybe you want to limit it to specific languages. So for instance, only Dutch, French, and English. And because you know that your data is in a specific language, that you can respond in a high quality on that one. These are input guardrails. These might stop your RAG program from even starting. There's also output guardrails that you can implement. Now, the first thing you want to do for the output guardrail is you can replay all the input guardrails. This can confirm that there's basically no kind of man-in-the-middle attack that's been going on, or that by accident there was a prompt injection. So these are things that you can just easily just replay, and it will ensure the quality of your output. Another one that you can do in the output check is tone of voice. Is the response generated by the LLM, is it polite? Is it coherent? Is it relevant? Is it complete? And the last thing that you want to check for maybe is the hallucination check. You can confirm that the response that is generated from your LLM, is it relevant and is it grounded onto the data that we supplied it? Did it do hallucinations or not? Now, let's see RAG in action. I hope that my demo will go fine. Let me quickly see. So, today I prepared a small demo, and this is about the current search engine that we have on the Belfius website. So if a customer has a question, there is an FAQ section, and he can do a quick search. So what did we do? We took the data that's available in the backend of all these FAQs, and we put them in a vector database. And it happens to be that we use Elasticsearch as a vector database. And I will show you here in a minute how this data might look like. So this is how the data looks like in our Elasticsearch vector database. So you can see here, this is the embedding or the vector representation of the data. And let's see actually what the data was. And you will notice immediately vector embeddings, they're quite large, because this was actually the data, just 3 sentences. And we have not only the content, I think we have a second embedding that we do for the title. So this is what we have in our backend available. And this could be a simple extension of your current search process also. Just add an embedding field or a vector field. It depends on what your database is actually using. And you could just simply extend it. There is a lot of possibility there. So in our case, Elasticsearch as a vector database Data is embedded, vectors are created, and we can do a small search. So let's see if this works, I hope. So imagine I got a few questions prepared here. Imagine that I'm a victim of fraud, and I don't know what to do. I just know I'm a victim of fraud. Let's do a quick search. So in the backend, what's happening? We're translating the query into a vector embedding. We're hitting our vector database. We're getting relevant results. We're creating this big prompt or this big context that we're sending to the LLM, and the LLM will answer. So this is the answer that we get back. Yeah, sorry for those who are not Dutch speaking. I'll do an English demo in a second. So yeah, what does it say? It will immediately say which steps I need to take. I can block my cards. It'll actually give me a hyperlink to one of the Belfius pages that I can consult online. It'll tell me to block my account. It could tell me also to block maybe even the mobile application, if you're really doubtful on what's happening. You can also contact the Belfius Fraud department. It will explain what Belfius Fraud can do for you, what it can't do for you. It will tell you if you have seen maybe transactions that are doubtful, that you're scared about what's happening. Well, it will just say, okay, if you want to, I don't know how to call it in Dutch, in English, betwisten. It's if you don't agree, let's say, and you want to revert those things or get investigated, they give you a few links, and afterwards a bit of follow-up what to do after you contacted the Belfius Fraud department. So I have to say it's really nice, complete answer, and I know that this knowledge was divided between different knowledge articles or FAQs. So as a customer, I would have already consulted multiple pages to get the same information. So I talked about embeddings in a few slides back, and I said it's important to have multilingual embeddings. So why is it? Let's see. I'm going to do the same thing in English. I'm going to say I'm a victim of a fraud. Sorry. Maybe I'm a victim of a fraud here, but we'll see that afterwards in your comments. And it's not working. Come on. Oh, yeah. So this is also what can happen, and this is thanks to some guardrails put in place. If my input is like gibberish, it will be polite in answering. And hopefully I can select this one. Yeah. So again, my query is being embedded, vector search being executed, some documents are being retrieved, sent back to the LLM, and hey, we get the same thing, but now in full English. And if you look at the contents, you see that the formatting is quite different, but everything is still there. It will tell me how to block my card, block my account, maybe block the mobile application. It will tell me to contact the Belfius Fraud department. Not very detailed like it was before in the previous language, but it's still doing a very good job on getting the most important topics out there. And the nice thing about this is, if we look at the search results, what we were actually doing is we were working on a French dataset. So this is the power of the multilingual embeddings. It actually, in the end, doesn't matter in which language you're writing your documentation. Feel free to express yourself in your own language that you're comfortable in and that you know you won't make specific mistakes in your documentation. Let's see if we can continue. So we talked about RAG, and that was really Retrieval-Augmented Generation. A lot of use cases are about, I have a question and I want to find an answer. I want to find an explanation. I want to know how to do something. But GenAI can do a bit more than that. It can help you in your day-to-day life also. And also it helped me in even creating parts of this presentation. To give an example of what it can do, I took the content of the DevOps website, just did a select all in my browser, and I created a nice prompt. And you'll see that this prompt is really detailed. And it is important, or yeah, again, models are evolving very, very fast. And this was, let's say, what I was using 6 months ago. And 6 months ago, you really had to be very structured in your prompt. You would start with defining the identity. You would say, I'm an expert in content summarization. You take content in, you output in a markdown formatted summary using the format below. And then those were the important steps. Take a deep breath. Think step by step. It might seem a bit stupid or strange to tell that to an LLM, because LLMs are clever, they should know what they're doing, but actually it really helps to let the LLM think internally about what it should do and how it should complete the full prompt. And then we go further, we say, look, we need some output sections. Again, I actually use Markdown sometimes to define all these different splits, the identity, the output sections. And in the output sections, we ask, combine all of your understanding of the content into a single 20-word sentence in a section called one-sentence summary. And if you see on what's generated, that one-sentence summary is actually quite OK. So apparently, we have 200 speakers, and we have 3,500 attendees. I then asked to output the 10 most important points of the content as a list of no more than 15 words, blah, blah, blah. I'm going quickly over this. And I also ask for some 5 key takeaways. Now, honestly, the content of Devox's website wasn't too big, but imagine this doing on a transcription of a YouTube movie. Maybe even on one of the YouTube recordings here at Devox, you could send the transcription to an LLM, run this kind of prompt on it, and you got the gist of a presentation almost immediately. Now, we've been talking about RAG. RAG is quickly evolving, GenAI is evolving, and there's also a few new things popping up also. So, what are key things to keep in your mind, basically, that you need to be prepared for? What are the next steps to prepare for? One, stay modular towards your models. You've got closed source, open source models. The models of OpenAI are really good. We have models from Anthropic, Cloud are really good. We have Mistral coming up. A lot of nice models, pay-per-use models, pay-per-token models, but they're honestly sometimes worth the money. There's a lot of open source models that can be also helpful, and they're evolving also very fast. So stay modular, and also look out for the rapid evolution, of course, but benchmark for a use case. So it's not always needed to use the same big model for all your use cases. Sometimes a smaller, open source, cheaper model can do its job good enough. A good example is that the latest model from OpenAI, what's it called? 4o Mini, I think. 4o Mini. It's a mini model. We're not getting larger. We're taking actually a step back there. And this is a model that is smaller, cheaper than the original 3.5 of ChatGPT, but it's really good at handling specific tasks. So it's not the purpose that it will actually replace or become the next evolution. It's one of those things that become specialized. And the 4o Mini is specialized in handling specific, what we could say as tools or actions to be executed. And it's really a nice model. Now, like I said, RAG, it's a rapid evolving field. And there's multiple ways to improve RAG. And the market really, they haven't defined yet what's the best way. I think if we're talking about things like LangChain4j, those are frameworks that have been discussed many times here. They've not been around for a long time already. And there's more frameworks popping up all the time. Like I said, next steps, re-ranking. It's an important one. I don't see it enough happening. Chunk contextualization. We saw some naive chunking strategies, but why not ask your LLM indeed to make chunks based on the context? Hybrid retrieval process. There is a big value in that one. Hypothetical embeddings. This is a really cool one. With hypothetical embeddings, instead of doing the embedding of your query, so you ask a question, you embed that into a vector, and then you see if you can find some similar vectors in your vector database. That's really nice, but what if you would create a hypothetical answer? create an embedding based on that hypothetical answer, and then do your similarity check. There's also summary-based index, really interesting to look at also. And then the last point here is models context window. What do I mean by that? It's the context window of models are getting bigger and bigger. Like I said, there's like context windows of 1 million tokens that you could use, but maybe you don't want to use it all the time. And there's a specific moment where you want to choose, okay, I can put everything in my prompt, or I still need reg. You can still evaluate, and I would say be on the guard for information overload. Same as a human. If you would give him the whole book, he might have trouble remembering all the details. This is something that I found recently, and I do like it a lot. It is kind of the principle of height. Height is where you create a hypothetical document embedding or a hypothetical answer to check. And this is actually cool on the left side. So the context is you want to know how are the mutual relationships between the main characters. It's the main characters of the Harry Potter books. So what do we do normally in the reg principle? We get the query, we have this retriever process, and that retriever process will actually fetch a few documents. We send those documents to the generator, and then we get a nice answer. So here, what are we seeing? It's first, instead of immediately retrieving those documents, what if we could fetch some clues and build a bit of context? Maybe we can generate a draft answer and put that in input to your LLM. Maybe that can help. And in this case, the answer is a lot more elaborated, a lot more detailed. So this is one of these things, and this is what I wanted to say. Things are evolving very fast. And things are not always, let's say, validated before the next thing is popping up. The last topic I want to talk about, and of the future of RAG and the evolutions, are agents and multi-agents. So what do we see here? Again, on the top, we've got a user who has a query or a prompt. And here, we introduce the principle of a super agent or an orchestrator or a user proxy. It can have many names, but in the end, it's basically an orchestrator. And you will see that RAG is only one part of those things. So the agentic approach makes use of different agents that have each their own specialty. RAG can be one of them. You could have here on the left, you could have APIs. So you could have some logic that is calling APIs. You could have your LLM interacting with your database, because all these agents, they are LLMs, basically, or interactions with LLMs. And basically, there's no limit to what you can do with this type of thing. You can create agents that are looking into your own knowledge-based systems, looking into APIs that you've built internally, externally. Everything can be possible. So some advantages and some challenges here. Advantages, like I said, specialization, scalability. You make it's almost like microservices that you're building. So all these different kind of agents that can not only interact with an orchestrator, but can interact between each other also. They can be flexible, and they can be redundant. If one source is not working, you might get it from another source. There are some challenges, of course. You're building a quite complex system. Also, LLM's not the fastest, so latency can be a thing. And error handling is going to be not easy, because you don't know where my error is going to be originating, in which agent exactly. It's not an easy process. And the last thing here is, this is something I really like. I think this is a picture taken from the Microsoft AutoGen framework, which basically dynamically creates agents on the go. So we start out on the top left. We've got a user interacting with an agent or our orchestrator, and it says, plot me a chart of Meta and Tesla stock price change year to date. So our blue orchestrator agent, it will talk to a specialized agent, in this case probably a coding agent that knows how to code. And that coding agent can say, look, no problem, I've got some code for you to execute. And the orchestrator can execute it, can try to execute it, and it will say, okay, wait, I've got an error because the package Y-Finance isn't installed. It'll feed back to that coding agent. The coding agent says, hey, you've got a package missing. Do a pip install of the package, and it should be good. So yeah, orchestrator installing the pip. And eventually, we get a nice graph. The graph can be sent back to the user. The user can say, look, cool, but no, please plot the percentage change. Now, in the meantime, the orchestrator knows how to generate those graphs. It had the package installed, so it can easily regenerate the graph. And it can send it back as output. That's it. Thank you all for listening in. I would say, if you have questions, I'm going to be in the afternoon at the Belfius booth. So feel free to drop by. And if there's any questions that can't wait, I will be here for a few minutes also. Thanks all.